Hello everyone, welcome back to my YouTube channel. Myself Pranati, studying in Sri Venkateshwara College of Engineering in the Department of CSE Data Science. Today we are learning a topic in the data structures. The topic is binary tree transversal graphs and the terms of graphs. So let us go through this. Introduction. A binary tree is a hierarchical data structure in which each node has almost two children, refers to as the left child and the right child. The topmost node in the tree is called as the root. Each child of a node is itself the root of a binary tree known as the left subtree and the right subtree. Binary trees are commonly used in computer science for representing the hierarchical data such as directory structures, expression trees, and binary search trees. They are efficient for searching, inserting, and deleting elements when properly balanced. Binary tree basics. Some basic concepts about binary trees. Root, the topmost node in a binary tree. Node. Each element in a binary tree is called as node. Each node can have a value and reference to its left and right children. Parent, a node from which another node is descended. Every node in a tree expects the root as exactly one parent. Child, nodes directly connected to another nodes when moving away from the root. Leaf, nodes with no children. Depth, the length of the path from the root to a node. Height, the length of the longest path from a node to a leaf. Binary search tree, a specific type of binary tree in which the left child of a node contains only value of the node's value and the right child contains only value greater than the node's value. Transversal, the process of visiting all nodes. Understanding these basics will give us a solid foundation for working with the binary tree. Types of binary tree transversal. There are several types of binary tree transversal methods: in-order transversal, pre-order transversal, and post-order transversal. In-order transversal. In this transversal, the left subtree is visited first, then the root node, and finally the right subtree. Pre-order transversal. Here the root node is visited first, then the left subtree, and finally the right subtree. Post-order transversal. In this transversal, the left subtree is visited first and the right subtree and finally the root node. Depth first searching graphs. DFS is a graph transversal algorithm that explores as far as possible along each branch before backtracking. It can be used to traverse both directed and undirected graphs. DFS is often used to solve problems such as finding connected components, dictating cycles, and traversing a graph in a specific order. Breadth searching graphs. Breadth first searching graphs is another graph transversal algorithm that systematically explores all the vertices and edges of the graph, unlike depth first search, which explores as far as possible along which each branch before it's taken. BFS transfers the graph in layers, visiting all vertices at the current level before moving to vertices at the next level. Directed and undirected graphs. In an undirected graph, edges have no direction. Mathematically, an edge A, B is an undirected graph can be traversed in both directions. In directed graph, edges have a direction associated with them. If there is a directed edge from a vertex A to vertex B, it implies a way relationship from A to B. Complete graph. A complete graph is a simple undirected graph in which every pair of distinct vertices is connected to a unique edge. In simpler terms, a complete graph is a graph where every vertex is directly connected to the every other vertex in the graph. Subgraph. A subgraph of a graph is a subset of its vertices and edges that forms a graph itself. Subgraphs can be induced or non-induced. They are useful for studying properties of larger graphs and analyzing specific components. Path and cycle. A path in the graph is a sequence of vertices where each adjacent pair is connected by an edge. A cycle is closed path where the starting and ending vertices are the same except possibly for the first and last vertices. Both paths and cycles are fundamental concepts in graph theory and are used to analyze the connectivity and structure. Paths and graphs are fundamental concept in graph theory. A path in a graph is a sequence of vertices where each adjacent pair is connected by an edge. A graph is a collection of vertices. Graph can be directed or undirected. They can also be weighted or cost associated with them or unweighted within the graphs. Weight graphs. In an weight graphs, each edge has a weight or cost associated with it. This weight could represent various things depending on the application, such as distance, time, cost, or any other relevant metric operations. Understanding weight graphs is crucial for solving optimization problems in various domains, including computer networking, logistics, and resource allocation. And finally, the conclusion is, in conclusion, binary trees and graphs are a fundamental data structures used in computer science and various other fields. In summary, binary trees and graphs are both essential data structures with unique characters and applications. Understanding their properties and algorithms associated with them is crucial for solving a wide range of problems in computer science and beyond. Master of these concepts enables programmers to design efficient algorithms and solve real-world problems efficiently. Thank you, everyone.